The Montessori math program often amazes parents and elementary teachers alike. Montessori preschool students often graduate from their third year, able to do arithmetic into the thousands. Math skills many second and third graders still struggle with. In this video, we explore how the Montessori math program accomplishes this feat.
4,773.
In a Montessori preschool, students are prepared for math early. The sensorial activities, such as the brown stair, red rods, and pink tower, all come in multiples of 10. As soon as they have any sense of numbers, students start counting out crackers and fruit at snack time. The formal introduction to numbers happens with the number rods. Students already learn to order the red rods from shortest to longest. The number rods merely add color segments to the familiar material, and students count segments as they order the rods by length. Next, students learn to write numerals using sandpaper numbers similar to the sandpaper letters used in the language area. With the spindle box, children count out quantities of 0 to 9. Numerals and counters also reinforce the connection between numeral and quantity and indirectly introduce the concept of odd and even. These simple materials also provide opportunities to introduce basic arithmetic, such as here, where the teacher uses the familiar number rods, now with numerals, to introduce the concepts of addition and subtraction.
I'm going to take 4 away. How many's left? 6. I have.
Once students have mastered counting to 10 and can recognize and write numerals, they learn about larger numbers. We introduce them to the colored bead bars, and they build numbers 11 to 19 using the teen boards. The 10 boards apply this skill to make numbers to 100. The colored bead chains follow the same color scheme as the bead bars used with the teen boards. Students learn to count and skip count. Here, 2 girls are working with the 6 chain. A material much beloved by the children is the 1,000 chain. Here, a girl is counting its beads all the way to 1,000, labeling her work as she goes along and gaining a real grasp of large quantities. In parallel to these activities, students also learn about the decimal system and the basic operations of arithmetic, using the golden bead materials. Here, a child lays out unit beads, bars of 10 beads, squares of 100 beads, and cubes of 1,000. Students also learn to associate these quantities with the corresponding number cards. Once these materials have been introduced, teachers may ask students to fetch quantities. Here, a teacher asks the boy to bring 3,200s and helps him count to verify his work. Here, a boy has filled his tray with a large quantity of beads and is working with the teacher to find out how many beads there are. He counts his units, and when he reaches 10, he exchanges them for a 10 bar. He then counts 10 bars and exchanges them for 100 squares, and so on. In the end, he happily discovers the big number of 7,218 that stands for the quantity of his beads. Once students understand how to build numbers and exchange groups of 10, children begin to add numbers, learning that addition is putting quantities together. Here, 3 children each bring a quantity of golden beads of their choosing. They put together their units, tens, hundreds, and thousands. Then they count them all up, again exchanging every set of 10 for the next higher material. Needless to say, this way of adding makes it very real to children that addition is putting real quantities together. It is also much more enjoyable for young children than paper and pencil seed work. They get to manipulate actual things, interact with each other, and move about the room as they do their math work.
35 plus 2,345 plus 1,201, we came back with 4,891.
When students are very familiar with adding by putting together actual quantities using the golden beads, we introduce them to the stamp game. Here, quantities are represented more abstractly with colored, labeled squares. Instead of 10 bars, for example, students now work with a small blue stamp labeled 10. They build two numbers using these stamps, then put the stamps together and count them up. If needed, they know to exchange 10 stamps of one kind for the next larger kind, just like they learned when they exchanged 10 hundred squares for 1,000 cube with the golden beads.
Would you like to read your answer?
Subtraction and multiplication are introduced using the same materials. For example, multiplication is taught as repeated addition, such as here, where the boy uses the familiar stamp game to multiply by 3 by building the same number 3 times, then putting it all together. Now, students are ready to further explore the operations of arithmetic and to start memorizing math facts. Here, a girl works with the Addition Snake Game. She takes a number of familiar colored bead bars and creates a long chain. She then counts beads and exchanges colored bead bars for golden 10 bars to determine the number of beads in her snake. The snake game is a fun way to explore all the different ways of making 10 with other numbers. Students also practice checking their own work by arranging the beads in different ways, another essential skill for learning to think mathematically. Other materials help students move towards memorizing math facts. This addition strip board is used to practice addition facts and make addition fact booklets. With the subtraction strip board, students learn about subtraction facts. A variety of materials help keep the repetition needed to learn math facts interesting. For multiplication, we also use a range of materials. Skip counting bead change is the starting point. Here, a boy explores multiplication by 5, by counting up blue 5 bars and exchanging them as appropriate into golden 10 bars. Here, another boy builds other multiplication tables with the colored bead bars. This boy is exploring multiplication with small red beads and makes his own multiplication booklet, again moving towards memorizing math facts using a variety of activities to keep the work interesting. Our math program also includes applied math skills. Here, students learn about coins and relate the 100 cents in the dollar to the familiar 100 square of golden beads. Here, two girls are learning about telling time. Here, another girl learns about fractions. With this preparation, our students are ready for more advanced, more abstract math in elementary. All the materials are consistent. They use the bead bars to master long multiplication. They find their familiar colors of green for units, blue for tens, reds for hundreds in the division materials, as well as on the large bead frame, and quickly progress to more abstract math, more complex problems, and numbers into the millions. That is what a great preschool math program makes possible.